In this module, you will learn about bijective functions. You have learned that a function f from a to b is said to be 1, or injective if every element of a is mapped to a unique element of b. That is, no two elements of a are mapped to the same element of b. Here function f satisfies this condition. So we can say that f is 1. You have also learned that a function from a to b is said to be an onto or a surjective function if every element of b has at least one pre-image in a. Here, function f satisfies this condition also, and hence it is an onto function. Thus function f from a to b is both 1 and onto. Such a function is also known as a bijective function or a bijection. Mathematically, a function f from a to b is a bijection if it is both 1 and onto. Consider a finite set X with the elements a, b and c. Let us define a function f from x to x such that it is a 1 mapping. Then every element of domain X has its own unique matching element in codomain X. That is, two elements from the domain of F cannot point to a unique member of codomain X. So the range of function f has three elements a, b and c. This shows the range and the codomain of the function f are equal. Recall that if the codomain and the range of a function are equal, then the function is onto. Hence, the 1 mapping defined from x to x is also an onto mapping. More generally, for a finite set X, a 1 function f from x to x is necessarily onto. Also, an onto function f from x to x is necessarily 1 for every finite set X. Let's prove it. Consider the same finite set X and let f be an onto mapping from x to x. This implies the range of f is equal to the codomain of f. We have to show that f is 1. Let's begin by supposing that f is not 1-to-1. That means two elements from the domain of x are mapped to the same element in the codomain of f. Suppose b and c are mapped to a under f. Now, we are left with one more element a in the domain of f that can be mapped to any one of the remaining two elements in the codomain of f. Let a be mapped to b. This shows that the range of the function is not equal to the codomain of f. This is a contradiction to the fact that the range and the codomain of f are equal. Hence, an onto function defined from a finite set to itself is always 1.